we're going to start exploring logarithms. This is in the enVison's Algebra 2 book, topic 6, lesson 3. We're going to loosely base this off of example 1. We're going to define what a logarithm is and why we would want to use it. So back in Algebra 1, maybe even pre-algebra, you were introduced to 2x equals 8. And as an instructor, as a book would ask, what's the value of x? Well, this is pretty easy to solve because these are two separate factors, which means we can manipulate these a little bit easier. One doesn't actually rely on the other for the solution. And so I could get x equal to 4. Well, what if we change this up? What if I said this is the base of 2 to the power of x equals 8? Well, you might want to still do the same thing because you see that it looks like it's kind of multiplied, but it's not really. It's actually raised to the power. And if you remember from previous videos, I told you that this 2 is the base. This 2 is what's keeping this x grounded. And so if I just divide it by 2, this x is kind of like a balloon. It's like up in the air. And if you remove the person holding the balloon will go off into space, or in the atmosphere, not all the way to space. So this base of 2 is holding this exponent to this equation. So we cannot just divide by 2. Right? So one thing we can do is we can look at the second value, and I know just from experience that that is a base of 2 to the power of 3. And I can easily solve this as x equals 3. Another thing that I can do is I could use the inverse of an exponent. And what is the inverse of an exponent? What does that even look like? So the inverse of an exponent function is a logarithm. So if I had something like the base of 2 to the x equals some value y, what the inverse here would look like would be this log of your base of y will give you x. All right, and so we can use this idea, we can use this transformation, well, not really transformation, but this conversion to find my solution. So this right here is called a logarithm, and we truncate it just for log. So we have a logarithm of base b, these bases are the same, of y, these solutions are the same, equals x, and these exponents are the same. So to solve the equation 2x equals 8, we can rewrite this. So 2x equals 8 can be rewritten as log of my base of 2, of 8, of my solution there, is equal to x. And the way we read this is the logarithm base 2 of 8, or I typically say log base 2 of 8 is equal to x. The logarithm base b of x is defined as the same thing. You have to have your b is greater than 0. You can't have a negative b. So you cannot have a negative base. You cannot have a base of 1 because, again, it goes to that exponential. 1 to any power is 1. And your x itself has to be a positive number. We cannot have negatives with bases, just like you cannot have graphically negative with exponents. The logarithm function of b is the inverse of the y equals b. So these are inverses of each other. All right, so solving this, you would actually have a function in your calculator. It's going to be under math, and then I believe it's under math, and then it's log base if you have a TI-84. And you can insert this into your calculator and you'll get the answer of x equals 3. Another thing to think about what log can mean is what power. what power do I have to raise 2 to get the value of 8? And I have to raise 2 to the power of 3 to get the value of 8. All right, so this is the introduction of what a logarithm is. It is the inverse of an exponential. You can use logs to solve for exponentials, and you can use exponentials to solve for logs. All right, so there we go. The different parts of the log. If you have any comments or questions, please feel free to ask, and I will see you in the next video.